Hello everyone. In a previous class, we discussed about the BJT, means bipolar junction transistor, its working principle, symbolic diagram, classification of BJT, and the configuration of bipolar junction transistor, input as well as the output characteristics of the BJT. In this lecture, we will study about what is junction field effect transistor, in short JFET. FET and its classification, means field effect transistor and its type. After this, comparison of connection between the junction field effect transistor and bipolar junction transistor. After this, we will move on the output characteristics or the VI curve of a typical junction field effect transistor. The next topic is modes of FET, means field effect transistor. Next, the JFET amplifier, means junction field effect transistor used as an amplifier. And finally, the reference of this presentation. So in this lecture, we covered all these topics one by one. So let's start with topic 1. The introduction of JFET, means junction field effect transistor. The junction field effect transistor, or in short JFET, is a voltage controlled 3-terminal unipolar semiconductor device available in N-channel and P-channel configuration. In the bipolar junction transistor, we saw that the output collector current of the transistor is proportional to the input current flowing into the base terminal of the device, thereby making the bipolar transistor a current operated device, as a smaller current can be used to switch a large load current. तो सिंपल लैंग्वेज में हम JFET का डेफिनेशन बोल सकते हैं कि इट्स अ 3-टर्मिनल डिवाइस, इसके 3 टर्मिनल होते हैं और बेसिकली 2 टाइप्स का होता है JFET, N चैनल और P चैनल, जो कि अभी हम नेक्स्ट स्लाइड में देखेंगे डिटेल फॉर्म में. तो इसके जो 3 टर्मिनल होते हैं वो होता है सोर्स, ड्रेन एंड गेट. नाउ द सेकेंड टॉपिक इज फील्ड इफेक्ट ट्रांजिस्टर, इन शॉर्ट FET. The field effect transistor, or simply FET, however, uses the voltage that is applied to their input terminal, called the gate, to control the current flowing through them, resulting in the output current being proportional to the input voltage. As their operation relies on electric field, hence the name field effect, generated by the input gate voltage. This then makes the field effect transistor a voltage operated device. So this is the most important things. The FET and JFET are the voltage operated device. What is field effect transistor? The field effect transistor is a 3-terminal unipolar semiconductor device that have very similar characteristics to those of their bipolar transistor counterparts. Field effect transistors can be made much smaller than an equivalent BJT transistor, and along with their low power consumption and power dissipation makes them ideal for use in integrated circuit, in short IC, such as CMOS, a range of digital logic chips. We remember from the previous lecture that there are two basic types of bipolar transistor construction, NPN and PNP, which basically describes the physical arrangement of p-type and n-type semiconductor materials from which they are made. This is also true of FET, as there are also two basic classification of field effect transistor called the N-channel field effect transistor and the P-channel field effect transistor. This is the diagram for N-channel junction field effect transistor. The field effect transistor is a three-terminal device that is constructed with PN junction within the main current carrying path between the drain and the source terminal. This is the typical field effect transistor diagram. These terminals correspond in the function to the collector and emitter respectively of the bipolar junction transistor. The current path between these two terminals is called the channel, which may be made of either a p-type or an n-type semiconductor material. The control of current flowing in this channel is achieved by varying the voltage applied to the gate. As their name implies, bipolar transistors are bipolar device because they operate with both type of the charge carrier, holes and electrons. The field effect transistor, on the other hand, is a unipolar device that depends only on the conduction of electrons in N-channel or holes in P-channel. So this is the basic difference between BJT and FET. The field effect transistor has one major advantage over its standard bipolar transistor, in that their input impedance Rin is very high, 1000 of ohms, while the bipolar junction transistor is comparatively low. This very high input impedance make them very sensitive to input voltage signals. But the price of this high sensitivity also means that they can be easily damaged by static electricity. So the next topic is the classification of FET. The field effect transistor is classified into two categories. First one is called JFET, means junction field effect transistor, and second one is called IGFET, means insulated gate field effect transistor. JFET is also further classified into two categories, N-channel and P-channel. There are two main types of the field effect transistor, the junction field effect transistor, in short JFET, and the insulated gate field effect transistor IGFET, which is commonly known as the standard metal oxide semiconductor field effect transistor, or in short MOSFET. There are two basic configurations of junction field effect transistor, is N-channel JFET and P-channel JFET. The symbols and the basic construction of both configuration of the JFETs means junction field effect transistor are shown in a figure. First one is a basic construction diagram of N-channel JFET and second one is called the basic construction diagram of P-channel JFET. And the symbolic representation of both type of junction field effect transistor is shown in a diagram. The junction field effect transistor has no PN junction but instead has a narrow piece of high resistivity semiconductor material forming a channel of either N-type or P-type silicon for the majority carrier to flow through with two ohmic electric connections at either end, commonly called the drain and the source respectively. There are two basic configurations of junction field effect transistor is the N-channel JFET and the P-channel JFET. The N-channel JFET channel is doped with donor impurities, meaning that the flow of current through the channel is negative, hence the term N-channel in the form of electrons. तो N चैनल को हम N चैनल क्यों बोलते हैं? क्योंकि इसमें जो हमारा फ्लो होता है वो नेगेटिव चार्ज के थ्रू फ्लो होता है और जो चैनल है वो नेगेटिव होता है, इसीलिए हम इस चैनल को N चैनल JFET बोलते हैं। तो नेगेटिव चार्ज हमारा इलेक्ट्रॉन्स पे होता है, मींस ये जो JFET है ये फंक्शन जो इसका है वो डिपेंड करता है इलेक्ट्रॉन्स के फ्लो पे। सो दिस इज कॉल्ड दी N channel junction field effect transistor. Likewise, the P channel JFET channel is doped with acceptor impurities, meaning that the flow of current through the channel is positive because अब जो flowing हो रहा है करंट का वो डिपेंड करेगा होल्स पे और होल्स पे हमारा पॉजिटिव चार्ज होता है, इसलिए हम इसको P channel junction field effect transistor बोलते हैं। Hence the term P channel in the form of holes. N-channel JFET has a greater channel conductivity or lower resistance than their equivalent P-channel or P-type JFET, since electrons have a higher mobility through a conductor compared to holes. This makes the N-channel JFET a more efficient conductor compared to their P-channel counterparts. Means N channel जो है वो ज़्यादा हमारे लिए यूजेबल होता है और एप्लीकेबल होता है। We have said previously that there are two ohmic electric connection at either end of the channel called the drain and the source. But within this channel there is a third electrical connection which is called the gate terminal, and this can also be a P-type or N-type material forming a PN junction with main channel. The symbols and the basic construction for both the configuration of JFETs are shown below. ऑलरेडी हमने अभी प्रीवियस वाली स्लाइड में इस डायग्राम को समझ लिया है, क्या है सिंबॉलिक रिप्रेजेंटेशन है एज वेल एज दी कंस्ट्रक्शन डायग्राम ऑफ N channel JFET and P channel JFET. The semiconductor channels of the junction field effect transistor is a resistive path through which a voltage VDS, means voltage between the drain and source, cause a current ID is called the drain current, to flow As such, the junction field effect transistor can conduct current equally well in either direction. As the channel is resistive in nature, the voltage gradient is thus formed down the length of the channel, with this voltage becoming less positive as we go from the drain terminal to the source terminal. The result is that the PN junction therefore has a high reverse bias at the drain terminal and a lower reverse bias at the source terminal. This bias causes a depletion layer to be formed within the channel and whose width increases with the bias. The magnitude of the current flowing through the channel between the drain and the source terminal is controlled by a voltage applied to the gate terminal, which is reverse biased. In an N-channel JFET, this gate voltage is negative, while the P-channel JFET, this gate voltage is positive. तो नॉर्मली हमारा जो एन चैनल होगा उसमें जो गेट वोल्टेज की वैल्यू रहेगी वो नेगेटिव रहेगी और पी चैनल जो रहेगा उसमें हमारी जो गेट वोल्टेज की वैल्यू रहेगी वो पॉजिटिव रहेगी. The main difference between the junction field effect transistor and a bipolar junction transistor device is that when the JFET junction is reverse biased, the gate current is practically zero, whereas the base current of the BJT is always some value greater than 0. Biasing of an N-channel JFET. This is the diagram, constructional diagram of N-channel JFET. The three terminal name is source, gate and drain. The cross-sectional diagram show an N-type semiconductor channel and P-type region called the gate diffused into the N-type channel, forming a reverse biased PN junction, and it is this junction which forms the depletion region around the gate area when no external voltage are applied. JFETs are therefore known as depletion mode device. The depletion region produces a potential gradient which is of varying thickness around the PN junction and restrict the current flow through the channel by reducing its effective width and thus increasing the overall resistance of the channel itself. Then we can see that the most depleted portion of the depletion region is in between the gate and the drain, while the least depleted area is between the gate and the source. Then the JFET's channel conducts with zero bias voltage applied. That is, the depletion region has near zero width. With no external gate voltage means the value of Vg is equal to 0 and a small voltage VDS means voltage across the drain and source applied between the drain and source. The maximum saturation current IDSS will flow through the channel from the drain to source, restricted only by the small depletion region around the junction. If a small negative voltage minus VGS is now applied to the gate, the size of the depletion region begin to increase, reducing the overall effective area of the channel and thus reducing the current flowing through it. A sort of squeezing effect takes place. So by applying a reverse bias voltage, increasing the width of the depletion region, which in turn reduce the conduction of the channel. Since the PN junction is reverse biased, little current will flow into the gate connection as the gate voltage minus VGS is made more negative. The width of the channel decreases until no more current flow between the drain and the source, and the FET is said to be pinched off, similar to the cutoff region of the BJT. The voltage at which the channel close is called the punch off voltage, or we can say that pinch off voltage, VP, in short in VP. JFET channel pinched off. In this pinched off region, the gate voltage and VGS control the channel current and VDS has little or no effect. So this is the JFET model diagram. The result is that FET acts more like a voltage controlled resistor which has zero resistance when VGS is equal to 0 and maximum on resistance RDS. When the gate voltage is very negative under normal operating condition, the JFET gate is always negatively biased relative to the source. It is essential that the gate voltage is never positive, since if it is, all the channel current will flow to the gate and not to the source. The result is damage to the JFET, then to close the channel. No gate voltage VGS and VDS is increased from 0. No VDS and gate control is decreased negatively from 0. VDS and VGS varying. The P-channel junction field effect transistor operates exactly the same as the N-channel above, with the following exception. Number 1, the channel current is positive due to holes and the polarity of the biasing voltage need to be reversed. So the next topic is comparison of connection between JFET and a BJT. So the relationship between the connection of junction field effect transistor and bipolar junction transistor are compared below. In a BJT, there is a 3-terminal emitter, base and collector denoted by E, B and C respectively. But in case of FET, the emitter is called a source represented by S, base terminal is called the gate, in short G, and drain is the collector terminal. So in BJT, emitter, base, collector, 3-terminal. In field effect transistor, source, gate and drain is the 3-terminal. Next is output characteristics. The output characteristics of an N-channel JFET with the gate short circuited to the source is given as. So this is the output characteristics of N-channel junction field effect transistor. The voltage VGS applied to the gate controls the current flowing between the drain and the source terminals. The VGS refer to the voltage applied between the gate and the source, while the VDS is referred to the voltage applied between the drain and the source. Because the junction field effect transistor is a voltage control device on current flowing into the gate, then the source current IS flowing out of the device equal to the drain current flowing into it, and therefore ID is equal to IS. The characteristics curve example so above shows the 4 different reasons of the operation for a JFET, and these are as ohmic reason. When the VGS is equal to 0, the depletion layer of the channel is very small and the JFET act like as a voltage control resistor. Cutoff reason. This is also known as the pinch off reason, where the gate voltage VGS is sufficient to cause the JFET to act as an open circuit as the channel resistance is at maximum. Next is saturation or active reason. The JFET become a good conductor and is controlled by the gate source voltage VGS, while the drain source voltage has little or no effect. Breakdown reason. The voltage between the drain and the source VDS is high enough to cause the JFET's resistive channel to break down and pass uncontrolled maximum current. Is called the breakdown reason. The characteristics curve for a p-channel junction field effect transistor are the same as those above, except that the drain current ID decreased with an increasing positive gate source voltage VGS. The drain current is 0 when VGS is equal to Vp. For normal operation, VGS is biased to be somewhere between Vp and 0. Then we can calculate the drain current ID for any given bias point in the saturation or active region as follows. Drain current in the active region ID is equal to IDSS in bracket 1 minus VGS divided by Vp whole square. Note that the value of drain current will be between 0 and IDSS maximum current. By knowing the drain current ID and the drain source voltage VDS, the resistance of the channel RDS is given as RDS is equal to del VDS divided by del ID is equal to 1 upon Gm, where Gm is the transconductance gain. Since the JFET is a voltage control device and which is represent the rate of change of the drain current with respect to the change in a gate source voltage. The next topic is modes of FET. Like the bipolar junction transistor, the field effect transistor, being a 3-terminal device, is capable of 3 distinct modes of operation and can therefore be connected within a circuit in one of the following configurations. First one is common source. This is the diagram of common source configuration. In a common source configurations, the input is applied to the gate and its output is taken from the drain as shown in a figure. This is the most common mode of operation. The FET, due to its high input impedance and good voltage amplification, and as such common source amplifiers are widely used. The common source mode of field effect transistor connection is generally used audio frequency amplifier and in high input impedance pre-amplifiers and stages. Being an amplifying circuit, the output signal is 180 degree out of phase with the input signal. Second is common gate configuration. In a common gate configurations, the input is applied. This is the diagram of common gate configuration. The input is applied to the source and its output is taken from the drain, with the gate connected directly to ground 0 volt as shown in figure. The high input impedance features of the previous connection is lost in this configuration as the common gate has a low input impedance but a high output impedance. This type of FET configurations can be used in high frequency circuits or in impedance matching circuits where a low input impedance need to be matched to a high output impedance. The output is in phase with the inputs. Third is common drain configurations. In a common drain configurations, the input is applied to the gate and the output is taken from the source. The common drain or source follower configurations has a high input impedance and a low output impedance. A near unity voltage gain so is therefore used in buffer amplifier. The voltage gain of the source follower configuration is less than unity and the output signal is in phase 0 degree with the input signal. This type of the configuration is referred as common drain because there is no signal available at the drain connection. The voltage present plus VDD just provide a bias. The output is in phase with the input. Just like a bipolar junction transistor, JFETs can be used to make signal stage class A amplifier circuit with the JFET common source amplifier and characteristics being very similar to the BJT common emitter circuits. The main advantages JFET amplifier has over BJT amplifier is their high input impedance, which is controlled by gate biasing resistive network formed by R1 and R2 as shown in a figure. The common source amplifier circuit is biased in class A mode by the voltage divider network formed by resistor R1 and R2. The voltage across the source resistor R2 is generally said to be about 1/4 of VDD but can be any reasonable value. So these are the formulas of Vs, Vg and Id. Source voltage, gate voltage and the drain current. The required gate voltage can then be calculated from the Rs value. Since the gate current is 0, Ig is equal to 0. We can set the required DC quiescent voltage by the proper selection of the resistor R1 and R2. The control of the drain current by a negative gate potential make the junction field effect transistor useful as a switch, and it is essential that the gate voltage is never positive for a n-channel JFET, as the channel current will flow to the gate and not the drain, resulting in damage to the JFET. The principal operation of p-channel JFET are the same as the n-channel JFET, except that the polarity of the voltage need to be reversed. In the next lecture about transistor, we look at another type of field effect transistor called as MOSFET, whose gate connection is completely isolated from the main current carrying channel. नेक्स्ट लेक्चर में हम MOSFET के बारे में देखेंगे, उसका पूरा डिटेल स्टडी करेंगे. Next is the references. So these are the references. And anybody have any doubts, so please ask me, and thanks for watching this video.